All right, AP Calculus, let's go ahead and get started right away. So here we are. These are the homework set problems that I asked you. And I'll go ahead and go over what I think are the ones that were the most challenging and pretty much every problem. So you'll have some tutorial videos on this, and I think that'll be very helpful. All right, so first and foremost, the question says if the limit as x approaches a of f of x equals L. So basically what that's saying is as we approach a, okay, I don't know, I'll grab it over here. A could be positive or negative, right? But it doesn't specify, so we'll just call it A. That means as we approach A, right? It doesn't say it, but when it doesn't have the plus or the minus, we have to take in consideration both the left and from the right. So we could have something that looks like this. Okay, the limit as x approaches a from the left and from the right, well, we get closer and closer to this y value, which happens to be L. Okay, that's all it's saying. It says which of the following must be true. All right, well, it says A, that means f of A equals L. F of A is equal to L. Well, look, I just made an example that violates number one, right? It doesn't have to exist there, right? It's undefined because the limit just means that we approach it from the left and the right, and it's okay for us to have a hole. So we know this is not true. This is false. I just made an example that showed that. Well, it says here, from the left, it has to approach L. Well, it does, right? From the left, it has to approach L. That's true. And from the right, it has to be true. So in order for it to approach L, it has to be from the left and from the right. And this is why I like this question, because it's having us think about, all right, what does it mean to take the overall limit? What is the y value approaching? All right, what is the y value as we approach A from the x-axis? Well, we have to take into consideration the left and the right. Therefore, we can conclude that it has to be C, 2 and 3 only. Okay, thank you very much. All right, let's go ahead and move on. All right, problem number 2. This problem here looks very tricky. Again, I see x squared as the lowest term on the numerator, so I want to factor that out. All right, so we're going to get the limit as x approaches 3, and I'm going to factor it out. So we're going to get x squared. I'm going to get x squared plus 7x plus 12. All divided by, now this is a little tricky, and I'm going to show you kind of how this works. Let's say we have 4 times x minus 4 times x plus 3. Okay, well, if you notice, all right, both of these expressions have a 4, and I could just pull the 4 out, and we're going to get x minus, okay, x plus 3. All right, now you'll notice we distribute the negative across. We're going to get 4 x minus 3, these cancels, and we get left with negative 12, because 4 times negative 3 gives me negative 12. And you can see all we did was just pull out a common 4. All right, if you wanted to, you could have distributed this in here. We would have got 4x minus 12, and you see these cancels out, and we get negative 12. All right, and that's exactly what we're going to do on the problem down below. But if you notice, we don't just have a number, we have a common factor. So you see x plus 3 here and x plus 3. So we want to pull out an x plus 3. And when we pull that x plus 3 out, well, what's the number that's next to the x plus 3? It's the x squared. So it's x squared and then minus 16. All right, if you wanted to, what we could also do, okay, if you want to verify it, right, we take this and we can multiply the whole thing to the first term. We're going to get x squared times x plus 3. And then we take the whole thing and multiply it to the negative 16. And we're going to get minus 16 times x plus 3. Okay, and that's basically what we're doing here. And that's how we can go about factoring. We're just kind of undoing this process here, all right? And so now that we have this here, we can go ahead and continue to simplify this even further. Well, we're going to have x squared. The top is going to be x plus 3 and x plus 4. Again, the reason why is 3 times 4 is 12. 3 plus 4 is 7. And down below we have, well, would you look at that? We have the difference of two squares. We have plus 4, and we're going to get x minus 4. All right. Now that we have this expression right over here, well, what do you notice? It's very nice. What we can do is we can cross these off here, and we can cross this off here, and we get the limit as x approaches. Oh, whoops. I meant to put a -3. I apologize. All right. The reason why I meant to put a -3 is because if you put a -3, we're going to get 0 in here, right? -3 plus 3 is 0. There should be a -3. All right. As x approaches -3, I apologize. You can just go back and fix it. It doesn't really change the way we started the problem. All right. But the reason is we can see that this cancels out. We can cancel out the x plus 3 and we're left with x squared divided by x minus 4. Now we could take the -3 and replace it in for the x's. So we're going to get -3 squared. -3 minus 4, we're going to get +9 on top and 4, 5, 6, 7 and -7 on bottom. So therefore we can conclude it to be -9/7, or keep it whichever way. These are the exact same thing. Okay, a little bit tricky. This is probably one of the more trickier ones, but again, with some practice I think we'll be just fine. All right, let's go ahead and look at this problem here. Again, these problems are challenging, but we'll try to make sense of it, right? We want to factor the numerator, and again, we can't plug in 12 because 12 minus 12 on the denominator is 0. All right, so I want to combine like terms. I want to simplify the numerator, but in order to do that, we have to, again, find a common denominator and put it into a single fraction. So we're going to have to multiply x over here, and we'll multiply by 12 over here on top and bottom. So I'm going to get 12 minus x all divided by 12x. Okay. Now that I have this expression here, now I can go ahead and rewrite it into my limit problem. The limit as x approaches 12, we're going to have 12 minus x divided by 12x divided by x minus 12. Okay. And ideally, I want to be able to cancel out this and this here, and so in order to do that, we just had to get kind of fancy and kind of cute, and we did a problem like this similar, and it's the same procedure every time. We're going to essentially pull out a negative, and we're going to get x minus 12 divided by 12x, all divided by x minus 12. Now again, I want to just verify so that you could see what I'm doing here. All right, negative times x is negative x, and negative times negative 12 is positive 12, and then I could just rewrite this as 12 minus x, which is this right here. Okay, so you can see all I'm doing is kind of like I'm factoring out a negative so that I can get the exact same factors to look identical. And once they do, we are in show business because I can cancel these out and we're going to be left with, well, there's a negative still there, -1/12. And that's my answer right there. Okay, again, with practice in due time, we should get pretty confident with these. Okay, now this is the last example, and this is probably the most challenging example problem, right? And let's go ahead and write it out. The limit as x approaches 9, and we have the square root of x plus 7 minus the square root of 16, all divided by x squared minus 81. Okay, now I'm going to multiply over here. I'm going to multiply by the square root of x plus 7 plus 16. Okay, and down below I'm going to multiply by square root of x plus 7 plus 16. Now you might be asking yourself, why in the world would I do something like this? Well, let me show you. If I have x minus 2 and x plus 2, you notice it's the same thing, except the only difference is this has a minus sign and this has a plus sign. And watch what happens as we distribute this out. We're going to get x times x, which is x squared. X times 2, which is plus 2x, and -2 times x is minus 2x, and last but not least, -2 times 2 is minus 4. Well, look what happens. 2x minus 2x cancels out. Our middle term cancels out, and we're left with x squared minus 4. So when we have opposite signs, when we have the same factors but opposite signs, the middle terms are just going to cancel out. And so what we can just do is multiply this across. All right. X times x is x squared, and -2 times 2 is minus 4, and we get the same thing. And that's why on the other problem above, we're just being very fancy with our algebra. We're multiplying by the conjugate pair, which just means the same exact thing except the plus sign. I did forget to put the square root of 16 over there. All right, therefore now they're identical except they have opposite signs, because I can just multiply, or do that because the middle terms are going to cancel out. Now I can just multiply this with this, just like I showed you with the other one, and square root times the square root cancels out. So we're going to get, let's just write the limit as x approaches 9. I'm going to get x plus 7, and then negative square root of 16 times the square root of 16. The square roots cancel each other out, and we're just going to be left with minus 16, all divided by, and I'll go ahead and factor the bottom, x plus 9 and then x minus 9, right? That gives me the x squared minus 81. And then I have this nasty expression in the denominator, x plus 7 plus the square root of 16. Okay, let's go ahead and simplify this a little bit down below here. So we're going to get the limit as x approaches 9. Well, 7 minus 16 is going to give me x minus 9. All right, that's pretty nice. I'm going to have x plus 9, and I'm going to have x minus 9 on the bottom, and we still have the square root of x plus 7 plus the square root of 16. Okay, well, if you look, these factors are going to cancel out. All right, and so now that these cancel out, now we can go ahead and write it as the limit as x approaches 9 of 1 divided by x plus 9 and the square root of x plus 7 plus the square root of 16. Now I can take the 9 and distribute it in. I can take the 9 and put it in for all the x values because I'll no longer get a 0 on the bottom. And so now we're going to get, well, if I plug in 9 here, I'm going to get 9 plus 9, which gives me 18. Okay. Down over here, I'm going to get the square root of 9 plus 7 plus the square root of, well, the square root of 16 is 4. Okay. This right here is the square root of 16, and that also becomes 4. So on the denominator, I'm going to get 18 times 4 plus 4. Okay. And I'm going to get 1 over 18 times 8. All right. And we're going to get 1 divided by 18 times 8, I don't even know what that is. I could do it by hand, all right, but I'll just use my calculator for efficiency's sake, and it's going to give me 144.